Alright, here we have another trigonometry equation, but this time you're going to see that instead of just an angle x, I have an angle of 3x inside the trig. Again, if we go back to the very first problem, the reason our inspiration for this, we could probably already take care of a couple of the steps now. We can say I can subtract away the 12. So I've got negative 1.5 equals 3 times the sine of all this stuff. Bracket 2 pi over 365, x minus 79. I could divide everything by 3 now. And when I do that on the right side, I get just negative 1/2 equals the sine of bracket 2 pi over 365, x minus 79. So those steps are consistent with what we tried on the other problems, but instead of just a nice x in here, we have this 2 pi over 365 times x minus 79, creating a bit of a nightmare. And so we're going to go ahead and go a little bit more slowly and just have a 3x in here. So that's a little more basic. Overall, the idea is the same. There is some angle, 3x, that has a sine of negative 1. Our goal is to find that. But when there is a coefficient in front of your x, or just anything besides just one simple variable in there, my recommendation to you is to replace that with a different variable. And so I'm going to go ahead and use r. I'm going to say that 3x equals r. That's my substitution step here. So that's us substituting out this 3x and substituting in an r. So the sine of some angle r is equal to negative 1. We can write it as inverse sine of negative 1 equals r. So we're looking for some angle that has a sine of negative 1. Hopefully, by just spending just a second on your unit circle, you'll recognize that the angle that has a sine of negative 1 is 3 pi over 2, 270 degrees. So we're going to go back down to our problem here and say, all right, then r must equal 3 pi over 2 plus 2 pi k. This is, 2 pi n. This is one of the problems where there's only one angle in the first rotation that has a sine equal to negative 1. It's just 3 pi over 2. There's not a second angle that does that. And so that's the general solution. Now, if I asked you to solve a problem that has x as a variable, but you tell me that r equals 3 pi over 2 plus 2 pi n, I might be like, hey, man or woman, where did this r come from? There wasn't an r in the problem that I gave you. Why is there an r in your answer? So you've got to make sure you go back to after we've solved. So we've substituted out, we then solved. Now we've got to substitute back in. We've got to put this x back in for r. And so we can just write 3x equals 3 pi over 2 plus 2 pi n. From here, it's a simple get x by itself step, which is to divide by 3, but sometimes I think it's even easier if I just multiplied by 1/3. That will still get x by itself, but when I have the fraction on the right side, it makes it easier just to multiply by 1/3. So I'm left with x equals 3 pi over 6 plus, and you got to do the distributive property over here, 2 pi n over 3, or 2 pi thirds times n. You might want to just put the n at the end here. And so we get an x equal to pi over 2 plus 2 pi thirds n. That's the actual general solution to the equation that we wrote above. The equation we were trying to solve above. That's the general solution.